This lesson reviews the new Hyper-V features in Windows Server 2012 R2. I'm going to cover a number of these features in more detail in later lessons, but I wanted to give a high-level overview of all of the new features and demonstrate some of them in this lesson. Live migration was a major feature in Windows Server 2008 R2 that allowed a zero downtime migration of virtual machines between nodes in a cluster. This feature was enhanced in Windows Server 2012 to enable a shared nothing live migration, the ability to move virtual machines between any Hyper-V 2012 host, whether they were in a cluster or not, which could also move the storage if it wasn't using SMB as the storage location. Windows Server 2012 R2 builds on live migration in a number of ways. Firstly, during a migration, it's actually possible to live migrate a virtual machine from a Windows Server 2012 Hyper-V host to a Windows Server 2012 R2 Hyper-V host. This enables an upgrade to Windows Server 2012 R2 without affecting the availability of virtual machines. The other major change is around how data is actually sent over the network, which is the actual memory and device state of a virtual machine. If I look at one of my Hyper-V 2012 R2 servers and go to my Hyper-V settings, I see live migration, and I can see incoming and outgoing live migrations are enabled, the number of simultaneous live migrations I've limited to, and also which IP addresses or network adapters I wish to use. If I expand this, I see advanced features, and I now have three types of performance options for live migration. The first is TCP/IP, and this is the default in Windows Server 2012, and in fact the only option in Windows Server 2012. So this takes the uncompressed memory of the virtual machine and sends it over the network using a TCP/IP connection. This uses very little host resource, but can take up a lot of bandwidth depending on the amount of memory of the virtual machine and the rate of change. The new default in Windows Server 2012 R2 is compression. As the name suggests, this now compresses the memory, sends it over the wire, and then decompresses it on the target host. This uses up less bandwidth and actually accelerates the live migration process. Again, this could be by a factor of fourfold, so instead of taking 60 seconds, this may now take 15 seconds. The negative of this, however, is it does use CPU resources on both the source and the target, as data has to be compressed, then decompressed. However, this additional CPU usage is deemed worthwhile for the overall performance improvement. Another new option is SMB. This uses SMB Direct, which, if you've looked at SMB Direct, actually leverages the RDMA, the Remote Direct Memory Access capability of RDMA-capable network adapters. This provides the absolute fastest live migration experience with zero, or very close to zero, host usage in terms of the CPU, because the network adapter is now in charge of taking all the memory from the source Hyper-V host and sending it to the target without even encapsulating in TCP/IP packets. The network adapters are directly using RDMA. This can only be used, however, if you do have RDMA network adapters. So if you have RDMA network adapters, you should always use the SMB option for live migration. Hyper-V Replica was introduced in Windows Server 2012 as an asynchronous replication between Hyper-V hosts, and it would replicate every 5 minutes. In Windows Server 2012 R2, there were two major changes. The first is the granularity of the replication itself. If I look at one of my servers that is replicating, Savdal Apo1, I can see the replication tab to see the details. And if I select settings, I have a replication option. This now shows me the new granularity. I can replicate 30 seconds, 5 minutes, or 15 minutes. Additionally, Hyper-V Replica has been improved to enable extended replication. I can now take the target, the Hyper-V Replica, and replicate that. So now virtual machine can effectively be replicated to a second location and then replicated again to a third location. This is via the extend replication. I would then select the target node, select its own replication frequency, 5 minutes or 15 minutes, for an enhanced Hyper-V Replica experience. This is very useful as a number of organizations actually leveraged Hyper-V Replica within a single data center. Instead of using clustering and shared storage, they would replicate a VM between hosts in a data center. That's why the 30-second granularity is very useful, but also now with the extended replica, that virtual machine can still be replicated to a true disaster recovery, a second data center. Network virtualization was introduced in Windows Server 2012 as a means to abstract the networking that virtual machines see from the underlying physical network fabric. For example, the red network, the blue network, could have completely separate IP schemes than physically existed on the network fabric. However, there was no way to actually connect a virtualized network to another virtualized network, to a physical network out to the internet, or site-to-site type gateways. You had to use a third-party gateway. Windows Server 2012 R2 now includes a network virtualization gateway, which is managed using System Center Virtual Machine Manager 2012 R2. Generation 2 virtual machines provide a new set of virtual hardware for modern operating systems that understand virtualization, and I will cover this in more detail. VHDX was introduced in Windows Server 2012 as a replacement for the old VHD format. VHDX had the ability to be 64 terabytes in size, and in Windows Server 2012 R2, I can now share a VHDX file. For example, consider I wish to create a guest cluster, i.e. clustering within virtual machines. If I required shared storage in the past, I would have to use iSCSI or Virtual Fiber Channel or an SMB share. With shared VHDX, I can actually now take a VHDX file. For example, this is a shared VHDX, and under my advanced features, I can say enable virtual hard disk sharing. So you'll see this single VHDX file is actually connected to two different virtual machines, both of them sharing it. This shared VHDX must reside on a cluster shared volume because it's CSV that actually implements the sharing technology. So this can be directly stored on a CSV, or it can be accessed over SMB on a scale-out file server because scale-out file servers actually use SMB as its storage. Within the virtual machine, that disk just appears as shared SAS, so it can actually be used as cluster storage, and it shows here in this cluster as a clustered disk. Additionally, I can now dynamically resize VHDX files. So without having to shut down the virtual machine, I can actually take a VHDX file and I can resize it. I can effectively go and edit a disk. I select the disk I wish to modify. For example, here I'll just browse around and look at a disk. And I have actions to expand. And also, if there is unpartitioned space in the VHDX file, I can actually shrink as well. So I can expand and shrink VHDX files that are in use, which is a very useful capability. There is now storage quality of service, so I can enforce minimum IOPS and be notified if it drops, and maximum IOPS to actually enforce, and storage resource metering, which I will cover in more detail. Automatic virtual machine activation enables me to activate my Windows Server 2012 R2 data center Hyper-V server, and then any virtual machine that's running Windows Server 2012 R2, this could be standard, data center, or essentials, will automatically activate. It doesn't have to contact a KMS server or be AD joined. If it's running on an activated Windows Server 2012 R2 data center, it must be data center, that virtual machine will automatically activate. The only thing you have to use automatic virtual machine activation is to use the AVMA key. So when you type in the product key, type in the AVMA key, and it tells it to use AVMA as the activation technology. There's nothing else you need to manually perform or have running. There is a new enhanced session mode. This is enabled because part of the RDP protocol has actually been moved into the virtual machine services stack, and I will cover this in more detail. Virtual receive side scaling is very useful where you have virtual machines that have connectivity to high network links. For example, I have a virtual machine that has multiple processors that is connected to a 10 gigabit network adapter via a virtual switch. Typically, I would only see maybe 3 or 4 gigabits of bandwidth because the incoming traffic would only be processed by a single processing core. Receive-side scaling splits the traffic up over multiple cores so you can get the full bandwidth. VRSS now makes this available to Hyper-V virtual machines running on a Windows Server 2012 R2 host. Live cloning and checkpoint export are new ways to actually perform exports of virtual machines that are still running, which in 2012 was not possible, and we will cover this in more detail. Finally, enhanced support for Linux, specifically around dynamic memory, is now supported for Linux virtual machines that are running the latest distributions, and also there is now the ability to live backup from the Hyper-V host a Linux virtual machine in a file system consistent state. Effectively, Microsoft wrote a file freeze filter, so that when it performs a backup of the host, it freezes the state of the file system long enough to take the backup.